Welcome to the Explainer. Today, we're diving into a really fascinating technical investigation. We're going to pop the hood on a huge update in the programming world, Elixir 1.20 and Erlang OTP 29. We'll be walking through some phenomenal notes published by developer Ang back in June 2026. We're going to decode the clues and uncover a hidden mystery that, honestly, might literally be lurking in your own software projects right now. But hey, before we even look at a single line of code, I want you to consider something. Can technology actually be too boring? It's kind of a provocative thought, right? You see, when we rely on these incredibly mature, battle-tested tech stacks, we tend to get comfortable, maybe a little too comfortable. We just start trusting the system implicitly. We assume, hey, it's always worked this way, it's going to work this way forever. But does that comfort make us completely blind to unexpected, subtle breakages? Just keep that in the back of your mind as we go through this explainer.
All right, let's get into section 1, the beauty of boring, stable tech.
Let's kick this off with Ang's own words from their June 2026 notes. They wrote, "It's not that development on these two stacks has stagnated, it's just that they've long since become boring technologies." Man, I absolutely love that phrasing. In our fast-paced industry, we are literally always chasing the next shiny new framework, right? So calling Elixir and Erlang boring might sound like an insult at first, but as Ang points out, and as any seasoned engineer will tell you, it's actually a massive, massive compliment. So what do we actually mean by this? Well, boring tech basically refers to relatively stable software architectures that just operate day in and day out without massive breaking changes. It means predictability. It means, you can actually go to sleep on a Friday night and not stress out that your entire infrastructure is going to melt down just because some random dependency updated. The Elixir and Erlang ecosystem has reached this beautiful plateau of maturity. Developers trust it. It's this rock-solid foundation for massive scalable apps. But, as we're about to see, even the most solid foundations can shift just a tiny bit. Moving right along to Section 2, the OTP 29 surprise and those unexpected breaks. The number 29, more specifically, Erlang OTP version 29. Now, even though this ecosystem as a whole is delightfully boring and stable, major new releases, they're a completely different beast. A major release like OTP 29 almost always smuggles in a few subtle breakages. It's just the nature of the beast when evolving software at this kind of scale. You're fixing old bugs, you're optimizing performance, and sometimes, well, those deep under-the-hood tweaks have unintended ripple effects right up at the surface where we're writing our daily code. And this brings us to the inciting incident. Ang was just going through what really should have been a totally routine process, doing some modern CI pipeline upgrades. The goal was just to test existing code against the new Elixir 1.20.x and OTP 29 releases. Simple, right? Now, Ang notes how much this workflow has evolved. By 2026, using an AI companion to diagnose and fix breaks during these upgrades is just standard practice. It makes tracking down the root cause of a failing test so much faster. And it was actually during one of these routine upgrades, whipping up PRs to fix dependencies, that Ang and their AI companions stumbled on to a very sneaky, genuinely fascinating bug. Which takes us to Section 3, the breaking change. Let's track down the clues. Okay, let's examine the smoking gun. We've got this simple Erlang map with keys like changed, flash, foo, and bar. Looks harmless, right? But this specific map, when run through an iteration script, produced an output that literally stopped Ang in their tracks. The output for this exact identical piece of code suddenly changed depending entirely on which version of Erlang was running it. The environment shifted and the expected data output just shifted right along with it. We are going full detective mode on this one. Look at this. In older versions, we're talking Elixir 1.16 all the way up through 1.19.1, running on OTP 26 through 28. The keys print out in a very specific order. Changed comes first, followed by flash, then foo, then bar. It was totally consistent. But the exact moment the environment shifts to OTP 29, the output flips. All of a sudden, flash is printed first, and changed gets bumped down to the second position. No way, right? This, right here, brilliantly illustrates a trap so many of us fall into. Pre-OTP 29 starts with .changed. OTP 29 starts with .flash. Now, you might be wondering, okay, so what? Why does this even matter? Well, it matters because of brittle tests. Picture this. A developer writes a test that checks if the map exactly matches a hard-coded string starting with .changed. For years, that test passes with flying colors, green across the board. Then OTP29 drops. The internal ordering shifts, the string output changes, and boom, your entire test suite turns red, and your deployment is blocked. All because of a tiny shift in how two keys are ordered.
So, whose fault is this, really? Well, it brings us to a fundamental truth, the golden rule. Erlang maps have never guaranteed key ordering. Literally never. It has always been right there in the official documentation. But human nature is funny, isn't it? When a system consistently behaves a certain way for years, like consistently putting that changed key before the flash key, we just start treating that coincidence like a binding contract. We build our tests around it. We completely forget the golden rule because that boring, stable technology lulled us into a totally false sense of security.
Okay, so what actually changed under the hood to cause this flip? Ang's investigation revealed that has to do with the map lifecycle. When you create a map in Erlang, it starts its life as a small map in memory. As you cram more data into it, it eventually hits a threshold and transitions into a large map to keep things efficient. Well, it turns out OTP29 fundamentally changed the internal mechanics of how maps make that transition from small to large. That single optimization, buried deep in the Erlang virtual machine, naturally resulted in a totally different sequence when those keys are generated for output. So, what's the core takeaway for OTP29 map behavior here? First, the golden rule absolutely remains. Key ordering is not guaranteed. Do not write tests that rely on the order of keys in a map. Just don't do it. However, there is a really fantastic silver lining. While the overall order isn't guaranteed, the ordering is now entirely consistent among several different map functions starting in this release. So the Erlang team basically broke that incidental, accidental ordering of the past, but they replaced it with a much more robust internal consistency moving forward. It's a little short-term pain for some serious long-term stability. All right, let's pivot to Section 4, upgrading to mise and getting better tools.
Now, while Ang was deep in the trenches debugging these OTP29 map issues, they actually shared this highly practical side quest about local development environments. For years and years, asdf has been the standard tool in the Elixir and Erlang world for managing different language versions on your machine. And hey, it's solid. But Ang notes a recent transition to a newer tool called mise. Why make the switch? Simple. Mise offers significantly better support for a way wider variety of tech stacks outside of just Elixir. And the best part is, it remains fully backward compatible with all your existing asdf configuration files.
If you're thinking about optimizing your own workflow, here are the actionable steps straight from Ang's experience. First, just evaluate your existing asdf setup. Do you constantly find yourself fighting with version managers across a bunch of different languages? If the answer is yes, step 2. Install mise for that broader stack support. It's literally designed to be a drop-in replacement. And then step 3. Just enjoy the seamless backward compatibility. You don't have to rewrite a single configuration file. Mise just reads them, and it works. It's a brilliant little productivity boost that Ang picked up while just doing some routine maintenance. And that brings us to our final thought. We started this whole thing by asking if a technology could actually be too boring, and we saw firsthand how years of stability caused developers to completely ignore the golden rule of map ordering, which led to a bunch of broken tests in OTP29. So I'm going to leave you with this question to chew on. What hidden changes are lurking in your boring dependencies right now? What undocumented behaviors have you unconsciously built your entire test suite around? The next time you run a routine upgrade, take a closer look. Don't just look for what broke. Really look for why it broke. You might just uncover a fascinating mystery of your own. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.